Hello, everyone. Welcome to the TDWI webinar program. I'm Jim Powell, Editorial Director at TDWI, and I'll be your moderator. For today's program, we're going to talk about how to master your cloud data, best practices for success. Our sponsor is Tamer. For our presentations today, we'll first hear from Fern Halper with TDWI. After Fern speaks, we have a presentation and discussion with Anthony Dayton with Tamer. Before I turn the time over to our speakers, however, I'd like to go over a few basics. Today's webinar will last about 45 minutes to an hour. At the end of their discussion, our speakers will host a question and answer period. If at any time you'd like to submit a question, just use the Ask a Question area on your screen to type in your question and send it over. If you have any technical difficulties during the webinar, click on the Help area located below the slide window and you'll receive technical assistance. If you'd like to discuss this webinar on Twitter with fellow attendees, just include the hashtag TDWI in your tweets. Finally, if you'd like a copy of today's presentation, use the Click Here for a PDF line there on the left middle of your console. In addition, we are recording today's event, and we will be emailing you a link to the archive version so you can share this presentation with others or review it at a later time. Okay, today we're going to talk about how to master your cloud data, best practices for success. Our first speaker today is Fern Halper, PhD, TDWI Vice President and Senior Director of TDWI Research for Advanced Analytics. Well known in the analytics community, Fern has published hundreds of articles, research reports, speeches, and webinars on data mining and information technology during the past 20 years. Fern is also co-author of several dummies books on cloud computing, the hybrid cloud, and big data. At TDWI, she focuses on advanced analytics, including predictive analytics, social media analysis, text analytics, cloud computing, and big data analytics approaches. She has been a partner at industry analyst firm Hurwitz & Associates and a lead analyst for Bell Labs. Her PhD is from Texas A&M University. Fern, I'll turn things over to you here.
Great. Thanks, Jim. Hi, everyone, and welcome to this webinar on how to master your cloud data. We know that you're busy, and we really appreciate you taking the time to be with us. So what I'm going to do is I'm going to kick things off by talking about digital transformation. I'll talk about the cloud and how automated and applied AI tooling is being used in the cloud to help to master data. That'll take about 10 minutes. We'll spend the bulk of the webinar drilling deeper into some of these concepts with Anthony Dayton from Tamer. And we'll also, as Jim mentioned, have an audience Q&A, so be thinking about your questions around data mastering. So digital transformation changes the way that businesses operate. So if you think about some of the past digital transformations, these include things like the internet boom of the 1990s, the e-commerce wave of the 2000s. These actually changed the way that businesses operate. This wave is about transforming organizations and processes and products with data and analytics. So AI technologies like machine learning and natural language processing, they're at the core of this latest wave of digital transformation. And in fact, in a recent TDWI survey, and I'm going to talk about data from a survey from 2020, as well as one that's just coming out of the field now, we see these three sort of cogs. So if you look at the orange cog there on the left-hand side of your screen, we first see that 95% of respondents agreed with the statement that digital transformation is key to remaining competitive. So we've also seen that COVID-19 has accelerated the move to digital transformation. In fact, the majority of respondents with the survey that I just mentioned that's out in the field are saying that they've accelerated their digital transformation because of COVID. And as I said, data and analytics is at the heart of this recent wave of digital transformation, and organizations are dealing with diverse data. That's that green little cog in the middle there, talking about diverse data. So in fact, in these recent surveys, more than 50% were already dealing with data like internal text data. This is in addition, of course, to the structured data that everyone is familiar with. Many organizations are also dealing with semi-structured data and machine data and image data and other new data types. So this data is complex, and they want to move to analyze this data with more sophisticated analytics, aside from maybe just your basic slicing and dicing, to move to use things like machine learning, other forms of more advanced text analytics, other forms of more advanced analytics to analyze this data. And in many ways, that's driving the move to the cloud, which is the blue cog over there on the right, where I'm saying 80% of respondents to the survey that's just coming out of the field believe that the future is a hybrid environment that includes on-premises platforms and the cloud. So if you think about the cloud, it's providing scalability and elasticity for this new and complex data. It's providing the elasticity to enable more advanced analytics like machine learning that often requires a more iterative sort of approach. As you're training a model, that tends to be iterative. So there are many reasons why organizations are moving to the cloud. As I mentioned, often this is part of a multi-platform environment that keeps the traditional data warehouse maybe on premises for reports and dashboards, but moves more modern analytics to the cloud. Of course, there are other patterns as well. And organizations, as I said, have different reasons for moving to the cloud. Some may be collecting new data or data that's generated in the cloud, and they want to be able to analyze it there. Some may be doing pre-processing of data in the cloud and then bringing that business data back on premises for whatever reason, for the reports or dashboards. Some are doing their advanced analytics in the cloud. Some have a cloud-first mandate because of cost or other factors. So more organizations that we speak with are utilizing a cloud-first strategy, especially for moving new projects to the cloud. So this cloud-first strategy is a practice where businesses always consider operating a project or process in the cloud before any other means. And others are moving all but sensitive data to the cloud, and some are moving sensitive data to the cloud. And as I mentioned, others are using the cloud for more advanced workloads. As I mentioned before, compute-intensive workloads. They have a need to scale, and so on. They may set up sandboxes in the cloud environment, on a cloud data lake, or in a cloud data platform. They may run their models in production in the cloud. And most of this, a lot of this is due to a modernization effort, which we see many organizations undertaking. Now that's not to say, that we also see organizations looking at the cloud for opportunities. There are opportunities and challenges with anything. And if you look at some of the challenges and opportunities for the cloud, many are moving to the cloud. They see this as, in some ways, a catalyst, to do things like to improve data governance. And you see here 47% of organizations that we surveyed said data governance, can be an opportunity or a challenge. Data integration as well. And so we didn't specifically ask about things like data quality, but data governance includes quality and trust and integrity. So the move to the cloud may be serving to actually elevate the importance of data governance, because you need to be able to have strong data quality. Even in the cloud, you need to be able to trust your data, and it needs to have strong integrity. And what we see is that many organizations are looking at newer technology, like automation and augmentation, to help as they move to the cloud. So they're looking for these technologies actually to help to master this data, hence the title of the webinar. So for example, greater than 65% of respondents in that 2021 survey that I mentioned just before, they agree with the statement that that's listed here, that it's important to make use of intelligent tools on the market that incorporate AI and machine learning for profiling and transforming and processing data. So they want to be able to use these tools to do that. And more than 80% agree that tools that automate data management processes are key for success. So let me give you some examples of these tools. So for instance, some tools will use machine learning behind the scenes for identifying poor data quality. So the machine learning is actually infused into the software. So I'm not talking about things like just identifying missing data. I'm talking about the machine learning actually understanding, for example, the pattern of data and doing something like anomaly detection in the data, or knowing, even a simple example of like knowing that one address is the same as another, even though they look different. So for example, a couple of years ago, there was an interesting little open source project out there that, you could actually see how the machine learning was operating behind the scenes to do, this address matching. So for example, if your address was, 15 Northside Drive in Atlanta, Georgia, and there was another address that was 15 Northside with an N and then SIDE in Atlanta, and then maybe the abbreviation for Georgia, the tool would actually ask you, are these two the same thing? And you would say yes, and then the tool, would learn. Well, so fast forward now a couple of years, and the same kinds of machine learning are being infused into newer tools, tools that can also do things like look for outliers in a data stream using neural networks that are fitted based on historical data. And that's just one example in terms of a couple of examples in terms of data quality. There's also augmented tooling out there that does things like identifying sensitive data, for example, or doing data mapping. And we see this as a growth area at TDWI, and for good reason. It's because these kinds of tools can help you to master your data. This is important because less than 50% of respondents to our surveys at least say that they're satisfied with their data quality. So, in this latest 2021 survey, less than 50% were saying that they were satisfied with their data quality. But how are you going to build an organization that's going to digitally transform and use analytics and data if you don't trust the quality and you can't trust in the data? So the ability to master your data is going to be very, very important, and these tools can help with that. All right, so that is my introduction on the topic. We're going to move to a fireside chat and talk about all of these concepts in a bit more detail. So Jim, I'm going to turn it over to you to introduce Anthony.
Thank you, Fern. Just a quick reminder to our audience, if you have a question, you can enter it at any time in the Ask a Question window. We'll be answering audience questions in the final portion of our program. Joining us for our chat is Anthony Dayton, Chief Product Officer at Tamer. Anthony oversees product and solution strategies for Tamer's growing data mastering solutions. Anthony is most recently CMO at Celonis and Senior Vice President of Products at Click, and has over 20 years of experience building and scaling enterprise software companies. Anthony helped found the Employee Relationship Management business unit at Seawall Systems, and it grew to over 300 customers and $20 million a year in license revenue. He holds a bachelor's degree from Northwestern University and an MBA with high distinction from Harvard Business School. Welcome, Anthony. And Fern, I'd like to turn the chat back over to you.
Great. Welcome, Anthony. Before I start barraging you with questions, let's ask our audience a poll question. Which is this: what's the biggest benefit that you've seen from shifting to the cloud? I was talking about the cloud and the fact that organizations want to, put their data there. They want to do analytics. So if you've shifted to the cloud, what's the benefit that you're seeing? So the first answer is that we haven't shifted anything yet, and that's fair. We see about 25% of our audience not actually having shifted anything to the cloud. Have you seen a benefit with scalability or cost or time to value or access to the best technology, of course, because cloud providers provide access to new technologies, and many vendors that work with cloud providers have cloud native solutions that can be very important also. So Jim, do you want to push those responses? Are we getting some?
Sure. Here you go.
Give everyone a second. Okay, so again, 23%. They haven't shifted anything yet. That's less than my 25%, but probably not statistically significant. Scalability, yes. Obviously, we're seeing that scalability is a big benefit. Cost, interesting, because some people have gotten burned by cost, although when we ask our audience about cost, they'll say that it costs about what they expected. Time to value, for sure, and access to the best technology, lower on the list. So that's very interesting. All right, so let's drill more into the cloud and talk more about machine learning with Anthony. So Anthony, welcome. How about we start off with you telling us a bit about your background and what actually brought you to Tamer?
Sure, it's a great question. And as the introduction indicated, I've worked for many years in what I call the front end of the analytics challenge. How do we help people with their digital transformation efforts by allowing them to analyze data more effectively and push that analytical capability out to the organization? And that's a big part of what Celonis was and what Click did. One of the things that I saw as part of that work is that we were really, in a sense, we've sort of solved the problem of democratizing analytical capabilities. That's a sort of done and dusted capability. But when customers went to use those solutions, the underlying data was a disaster. So they were, they were able to build bar charts and line charts really effectively, but they couldn't trust the answers that were coming back from that analysis. And it's a point I think you made quite effectively in the presentation. And so I think what we're seeing is a shift in the market away from solving the front end of the analytics problem to working to solve the trust, governance, quality, manageability of the data that powers these enterprises and helps and really move that digital transformation effort back in the data value chain.
Yeah, I agree that we're definitely seeing trust. I wrote this in my article, What's Ahead in 21, that trust was going to be, the word for 2021. So I agree with you there and about the back end. And you mentioned, is there anything else you want to add about what's propelling organizations to actually move towards automated data management, say in the cloud as part of this back end?
Yeah, well, it's something you actually touched on in the presentation, but maybe I'll sort of underline it a little bit and highlight it. And that's really this issue of the cloud and machine learning, kind of the intersection between those two trends. So as you point out, and I think are spot on, organizations are digitally transforming, and this is not the first time that that's happened. The big difference today is the cloud, and you mentioned in the presentation this word elasticity, and I think that's a kind of key idea. Machine learning is an incredibly powerful platform technology. The problem with machine learning is that it requires a lot of compute. Right? These are very complex algorithms that need to operate against typically large amounts of data. And when, in the early sort of implementations of machine learning in customers, when cloud technology wasn't as available, people were standing up very large infrastructures, very complex infrastructures to utilize machine learning. What's amazing about the cloud is that you could now have, say, 1,000 machines working on a machine learning model, building a model for you in a matter of minutes. You can use those machines for a couple of hours and then throw them away. So the ability to have access to really large compute, use that to build really powerful models, really understand kind of unexpected nuances of the data, that's something that's very new. And it means that we can start taking machine learning-based approaches to some of these, what we talked about before, some of these back-end data challenges, where previously that may not have been possible. And we can we'll talk a little bit about how that manifests itself in the challenge of data mastering. But anyway, so I think that the cloud elasticity is that key driver, is that platform shift that's enabling new approaches.
Yeah, I definitely agree. And, when we talk to companies, they always say, yeah, our data warehouse is okay for now, but we know that ultimately, it's not going to be enough as we make this move, even from self-service, to doing more advanced analytics. They see that they're going to have to do something different. And oftentimes, that is, as I mentioned, moving to the cloud. But they do face, there may be some challenges and opportunities, in terms of mastering their data as they do move to the cloud. And of course, mastering data, even in the past to Power BI, that was a challenge, right? Dealing with garbage in, garbage out, data quality, all of that. So what did you see that organizations tried in the past, and how have they failed to drive meaningful insights, from enterprise data? And how does, I would also ask, how does Tamer help with some of that?
Sure. So, the sort of state of the art for doing mastering in the past has been this concept of master data management, rules-based master data management technology. And what's amazing to me, and having spoken to hundreds of customers and companies about this, is I don't think I've ever met anyone who was excited about an MDM project. It's like, yes, I get to work on an MDM project. It's going to be fantastic. Equally, I'm not sure I found a lot of MDM projects that have been successful. And the reason for that is actually sort of deceptively simple, which is they are rules-based systems for trying to impose quality and hierarchy and master data on systems of record. And anytime you try to impose a rule system on almost anything, you find that it sort of squeaks out the side, right? And people sort of work to avoid the system. And to make matters worse, it's effectively, from a purely technical perspective, impossible to write enough rules to really master the data, especially data of any scale. So if you have a small amount of data, a couple hundred records, a couple thousand records, maybe you could write enough rules to sort of manage that. Anytime you start getting any kind of data of scale, we find that these rule systems break down. You're effectively writing every corner case into a rule, and it becomes unmanageable. And there's a very specific technical reason for this, which is when you're dealing with data, you're looking at you need to compare each record to every other record, and that becomes an n-squared problem. So you're essentially, whatever the data size is, the number of comparisons that you need to do is the square of the number of records. And so very quickly, that's a geometric function, and very quickly that becomes unmanageable. So I think it's not a surprise that, these systems have not been wildly successful and are not well loved. So we talked about, at the beginning, about the availability of elastic cloud technology to train machine learning and to apply machine learning to a range of different tasks. What Tamer's done is build a machine learning system for mastering data. So rather than trying to build a whole series of rules, we train a machine learning model to do that work on behalf of the human being. We apply that technology to three big problems: schema matching, record matching, and record categorization. So schema matching says, are these two schemas the same schema? Are these two systems that hold data? How do I line these systems up? The second is the record matching. So I take a series of, say, customer records, and I say, are these customers the same customer? Right? And sort of collapse them. And last, record categorization, answering the question, I refer to this topic and this data source as this. Is it the same topic as a different data source? Are they, in fact, meaning the same thing? So this supplier is categorized this way. Is it categorized the same way? Or this part I'm buying is categorized this way. Is it the same in this other system? And so those are the three major sort of topic areas that we've built models to support. And then the last piece I would say is, the challenge with any machine learning system, something we can talk about, but is how do you train these models? And at its core, a lot of what Tamer has built is the system for thinking about how to collect human feedback into the system and train the model effectively and efficiently, right? You want to ask as few questions as possible of humans to train the model so that you can then get high quality data out of the system. And then you also want to be able to apply, so I made this point that rules are ineffective, and that's true, but there are cases in which a rule can be a very useful way of bounding the problem space that the machine learning needs to operate in. And so, you want to be able to do that as well. To summarize it, I mean, I think traditional machine learning, or rather sort of traditional master data management systems have largely been a failure. A new approach is necessary. The cloud enables a machine learning-based approach, and that's what powers Tamer.
Okay, yeah, so that is sort of similar, and it seems like you have some interactive capabilities that are similar in some ways to that small example that I was talking about, with the address matching and whatnot.
Exactly.
Yeah, so that's good. I always ask that, anyone I talk to, does the human interact with this? Okay, so, we definitely see that these types of tools, they're referred to as either applied AI tools or augmented tools. That there's a huge amount of interest in them in our audience. Even with the data quality tools, I think it was last year we did a survey and about, like less than 20% of organizations were using them in that year, but 50% more said that they were planning to use them. So, obviously organizations are really excited about this possibility. So what challenges, though, do you see your customers facing when they're adopting new technologies like machine learning to solve data challenges?
Yeah, so there are a number of different challenges. One of them you sort of alluded to, but let me make more plain. We want to get feedback from human beings to train the model. A model without training is useless. I really like this concept of applied machine learning. So, Tamer is not a generic machine learning platform that sort of does anything. It does a few things very specifically, and we've built very, tuned models to those. But those models need feedback. They need humans to engage them. One of the challenges of a sort of generic machine learning-based approach to this is you may end up requiring a ton of feedback from human beings. Right? To a lot of data you need to match, or a lot of data that needs to be processed. That could require a lot of training on the part of humans, and humans have a relatively short attention span for these things, and get tired of providing feedback. So one of the sort of core underlying concepts in Tamer is to figure out how to ask the minimum number of questions of humans to get the best benefit in terms of training the model. We call this concept of high impact questions. And the way to think about it sort of technically is if you think about sort of the feedback curve that you're getting on training your model, there's always this inflection point where a few extra points of feedback into the model have a really big impact on the efficiency and effectiveness of that model. And what Tamer's done is figure out how to maximize and figure out where that inflection point is. So it's only asking you questions where it has the most sort of confusion and where the benefit of answering that question will have the biggest impact on the model. So that's the first thing I would highlight. It's a very technically difficult problem, and I think one that obviously we've spent a lot of time thinking about and solving. And the second sort of challenge we see from a customer perspective is sort of what I call the black box problem. Anytime you build a machine learning algorithm, there's this sense that you're not quite sure why it's making the decisions that it's making, or the risk is that the machine learning is making a bunch of decisions, and the human is sort of questioning those decisions. So there's two things that we do, I think, that are smart here. Number one is giving people the ability to review the decisions the model has made and validate that, yes, actually, these things are true, or that they're not true, and providing that feedback. That actually goes as additional training data into the model. But the other is giving very clear feedback about what the model is doing, why it made the decision that it made. And that may give you great insight into, for example, additional data that so in your example of the addresses, one, and your example is spot on, but one thing you could do if you were getting poor matches out of that model is augment the addresses, for example, with their latitude and longitude. Right? You can add additional reference data into that may improve the fidelity of the model and have it make better decisions. So if you can understand why the ML is making the decisions it's making, you could then potentially enrich or augment that data with additional signal, which will make a better decision. So those are the two things I would sort of think about. How do you minimize the impact on humans, or maximize the value you're getting from training? And then secondly, how do you make sure that the machine learning is doing the work you expect it to, or think about how you would augment it to do better work?
That's really interesting. I mean, the first one's really interesting to me. I hadn't thought about that before, so that's really interesting. The second one I've always thought about in the context of just building machine learning models, that might predict churn or whatever. And, with the automated ML, it's really important to have some version of explainability, so you're basically saying, hey, here's what, the system learned, do you want to augment this, some more and get to something better. So you're sort of taking care of that as well. So what benefits are you seeing that your customers who are, using these augmented machine learning tools for data quality and other things in the cloud, what are they actually, what are the benefits that they're seeing in terms of using these tools to master their data?
Yeah, so oftentimes when we talk about benefits, what we're talking about are sort of incremental improvements in business outcomes. So, we reduce spend or we increase revenue or these sorts of things. And certainly I'll share some examples in a moment where that is true. But if I step back, so the number one thing I hear from Tamer customers is not that they see these sort of simple linear improvements in something, but it's the idea of possible versus impossible. What I mean is, in many cases, what Tamer customers are telling us is that, we had customer data spread across 100 different systems, and it was impossible to bring that data together and get a view of the customer. And so, and then we tried it using, a rules-based system, and it failed 3 times. And then for the first time ever using Tamer, we're able to bring that data together. And in my example, get a view of the customer that goes across business units or across systems or across whatever the silos of data that have caused the problem. So, and it's important in that idea is possible versus impossible. And I think this is a common feature of disruptive technology. And I've had the joy of working for many years across in many companies where there's a sort of disruptive technology which changes the dimension of competition and capability we can offer customer. And I think that's really what's going on here. If you try to bring together customer data from 100 different systems in a rules-based approach, and many of our customers have tried that, you are likely to fail. In fact, and you shouldn't feel bad because everybody else fails at that as well. It's effectively an unsolvable problem. Using this machine learning-based approach with Tamer, we see customers consistently succeeding at those projects, and for the first time ever. Now, with that as a backdrop, what we see is the application of this technology across a wide range of different industries, so financial services and the public sector, life sciences, the energy industry, manufacturing, entertainment, and we see a wide range of different sort of business value outcomes coming from that. The most sort of common of which is customer data. And I think there's having organizations get a handle on the relationship they have with customers is typically the simplest, biggest, most obvious value driver. And a lot of the data-driven work that we do as a company centers around how we can understand who are our customers, what are they buying from us, and how can we serve them better? Those are the sort of that. But there are other use cases we see, how we, who are our suppliers, where we buy from them, how we can, negotiate better pricing, what are the underlying parts in our systems, and how we can get a better handle on repairs and that sort of thing. One of my favorite unexpected examples is CAA, which is Creative Artists, which is the entertainment management company, looking at data about artists and how they share their view of the world through venues and exhibitions of their art, whether those artists are actors or singers or painters or whatever the type is. So that's a really interesting. Imagine trying to build that machine learning model. It's totally fascinating. But we see other examples like Toyota Motors in Europe looking at customer data, at GSK looking at clinical trial data, Hess looking at the data coming off of wells in the energy space. So it's a wide range of different use cases. Does that help?
Yeah, and so they're primarily, I guess a lot of these use cases that you mentioned are happening in the cloud, as I was mentioning, because it's compute intensive, and you were saying elasticity. So if organizations are evaluating solutions that are going to help them master their data, what do they need to be thinking about when it comes to cloud technology, in terms of the solution, working in the cloud? Is it more than that?
Sure. So, I'd say a couple things. The first is that, in fairness, I'm a biased observer here, but my view is that, you have to have a cloud native solution. You need something that's sort of built and born to take advantage of the highly elastic nature and scalable nature of the cloud. That to me is kind of table stakes. Other things I would think about that maybe are, so that to me is like a must-have. Other things I think that are important, system interoperability. Is this a system that says, everything will be done in my system and, now it's like a sort of a closed box, or is it something that's going to fit into a data ops architecture that you have inside your enterprise that really thinks about a range of different technologies and tools? And in particular, what we see with the cloud vendors is, there's a tremendous, and you actually sort of alluded to this in the poll question, access to new technology as a primary driver for why people are using the cloud. There's a tremendous amount of technology that's available through these cloud providers. And in a sense, it's really in the interests of organizations to be able to take advantage of that technology and have it fit and interoperate with other technology that they're running in the cloud. So I would look to cloud providers that have strong partnerships with the cloud providers that they work with, and sort of leverage or take advantage of the data movement technologies and data storage technologies, compute technologies that those cloud providers have. And then the last point I would make, which is maybe the most obvious, is scalability. Can you really take advantage of the elastic nature of the cloud so that you can, for example, run 1,000 machines against an algorithm? A lot of technology that was invented to run, on on-premise infrastructure, when you try to scale it to, billions of records of data, or large, elastic compute infrastructure, they just don't work. It runs on a single machine, virtual machine on the cloud, and that's fine. That's not good enough. It needs to really take advantage of this elastic nature of the cloud. And that's a very hard technical problem, I should say, but certainly something we can talk about.
Yeah, you're right. So you want to make sure that the vendor has a technical partnership with the cloud provider. It's cloud native, and well, if it's cloud native, it didn't have to be refactored, to actually, run that way. So that makes sense. So, if you're on the fence, about using some of these machine learning, applied AI, and you want to maybe think about improving on some rules-based approach, what would you recommend? If you're not really sure you want to move this way and you think that a rules-based system is probably okay to use, what would you recommend or tell some of the people that are out there about that?
Yeah, I mean, so, and this is true, I think, of almost any piece of technology, but my general opinion here is finding a practical, business problem with business owner sponsorship that you can engage on. And the number one example of that we see across customers with Tamer, especially as they begin their journey, is customer data, is getting a handle on that. One of the nice sort of underlying concepts of Tamer is that the more data you throw at the problem, the more sources you throw at the problem, the better the outcome. So what you might hear from, say, an MDM vendor, rules-based MDM vendor, is, oh, let's start with two things, and we'll try to bring them together, right? My view is that that's just solving an easy problem. I'd suggest going for a hard problem, and the hard problem would be, well, let's look at 1,000 sources and try to bring those together, right? That's a really hard problem, one where a model would be frankly, the only way you could achieve that outcome. But looking for a business driver and then thinking about what's the underlying data that enables that business driver. Question I ask prospects is, what are the strategic objectives of your organization? Maybe it's increasing cross-sell and upsell inside the customer base, cross divisions, or maybe it's lowering our cost to serve customers by more efficiently applying sales resources or marketing promotions against that customer base. Great, now we understand the primary business driver for your organization. What data sources drive that business outcome? And do you have a handle on those data sources? And then typically what we find is that that data is trapped in silos. It's across a range of different systems. It's of poor quality. And how can we bring that data together and then drive that business outcome through the application of really high quality data?
So the people that you're talking to, it sounds like they're business people. Are they typically sort of in the cloud already, or they have some data in the cloud and then they're going to bring more data into the cloud to answer the questions? And, is that who the buying person is in this case?
Yeah, it's a great question. I think of that question as the chicken and egg problem, like which comes first, the cloud or the mastering? And the answer is, I don't know.
Okay.
The analogy I always draw here is, if you're moving house, you should also take sort of stock of the stuff you own and clean up, right? It doesn't make sense, for example, to move your trash cans full of trash. Right? You want to empty your trash cans, get a handle on the stuff you have, and then move. It's hard to say which comes first. I think my general view is it's probably the move to the cloud that's coming first. As people are thinking about bringing data up into the cloud, they're also thinking about consolidating that data and getting a unified view of that data as they move it. That would seem logical to me. But also, in doing so, they have access to this highly elastic compute technology, which allows you to take a machine learning-based approach. So, which comes first, hard to say.
Right. And I want to leave time for questions from our audience. So I just want to ask you one last question is,
sure.
For those customers that are using your solutions, what outcomes have they seen? Have they been successful?
Sure. I mean, so, it's, all sorts of amazing stuff. So I indicated a couple of customers earlier, but quickly, at GSK, they're looking at clinical trial data across thousands of different studies and giving researchers access to unified data across those clinical trial data, which is quite literally allowing them to find and market new drugs, hopefully save lives. At Toyota Motors in Europe, they have customer data across 30 different geographies all around Europe. That data is in a wide range of different sources and formats and with different schema. And they want to get a view of that customer data across all of Europe at the Toyota Motors Europe level. They do that through Tamer. And then from a customer perspective, what it means is that if you have your car repaired, for example, in Italy, and then you show up in France, they know about that, and that they can then provide a much better class of service or buying experience if you're purchasing a car. So those are two sort of simple examples, that help illustrate that connection between mastering the data and the business strategies of these organizations and how they get value out of that.
Yeah, that all makes sense. I see a lot of questions coming in, and I was just looking at them. So what I want to do is to turn it back over to Jim so we can get to some audience Q&A. So Jim, back over to you.
Thanks, Fern. Let's start with this question for both of you. How do you recommend companies assign data ownership for the purpose of data quality requirements and assurance across platforms?
That's a whole nother webinar. No, it's a great question. It's all about data governance. And and the fact that data governance gets harder in the cloud, and what we see organizations doing is that they'll typically have, well, the ones that are doing it right. I mean, some of them will have like a steering committee that is more of a higher level group, and then there's a working group stewards in it, and the data stewards are responsible for the data quality. Philip Russum, one of our analysts, in his most recent best practices report about data governance, I mean, he was talking about like having some redundancy even with some of the roles. So I would, suggest people read that report. I think it's pretty interesting, in terms of some modern data governance, which gets into all of these issues. Anthony, I don't know if you have anything you want to add to that.
I do. So I think one thing is that software can really help this situation. And in particular, frankly, in a machine learning based approach where you're looking for user feedback on that data, it's practically a requirement. So one of the things we built into the software is the ability to elicit feedback and opinions from a wide range of different people in terms of the mastering process. So rather than relying on a single point of failure to say whether, for example, two records or using your example, two addresses are the same, you could actually get feedback from N or some bigger number, a number of people, and then look at that feedback and use it as a driver for what the right answer to that question is. And this is also an indication in a way of why the rules-based approach never works. It's because you can only have one rule. Right? You can't have 10 rules and have them sort of fight it out over what the right answer is. With machine learning, you can do just that. And so you can get feedback from a wide range of people. You can filter that feedback through your point, a data steward, who then adjudicates that rule that feedback, applies it into the model, and then the model can take that feedback and apply it across the entire data set. And that essentially is impossible in other schemes. So, I think it is a good question, and I think it's an important underlying concept.
All right, let's move on to this next question. How do you overcome the objection that MDM is too expensive and takes too much time?
I mean, I would agree that MDM is too expensive and takes too much time in the sense that traditional master data management, rules-based master data management, I would say not only is it too expensive and takes too much time, it rarely works. And it rarely works because it's fundamentally the wrong approach. It's a rules-based approach which imposes structure where where it's not effective. And so our view is that approach is fundamentally flawed, and what you require is a machine learning-based probabilistic approach to the same underlying challenge, but with a very different approach. I would encourage you, so one of the co-founders of Tamer is a gentleman named Mike Stonebreaker, and the origin of Tamer is academic research out of MIT exactly on this problem space. And Mike has a wonderful paper he's written, and then he's done it as a sort of webinar as well, around essentially why rules-based MDM kind of will always be a failure, and a failure in the sense of like it will never work because it's sort of set up to fail. It simply can't scale. So if it's interesting, if the topic's interesting to you, if you Google it, I'm sure it'll come up. It was probably on our website as well. Great. And Mike's how do you say this? He's a very opinionated guy, so it's a very strong point of view on the topic.
I just have this vision, I just have to say this, of a company that will remain nameless that I worked at many years ago. And, they were doing an MDM project. And I remember I was sitting, in some space where all of us were working, and I looked out the window of a corridor and I saw a bunch of guys, with briefcases sort of walking down the corridor. And I was like, what's going on? And they said, this is the latest group that's trying to solve the master data problem, and it had failed multiple times, sort of in the past. Anyway, I just had that vision as you were talking.
I think that feeling that you have and that experience is one that is sadly very common. And again, like it's not that people are bad. It's that the approach is a fundamentally flawed approach, because you will never build enough rules and impose enough hierarchy to achieve, high quality data to answer business problems. It's not that people did the wrong thing. It's just that, it's a little bit like, with a horse-drawn carriage, you were never going to, solve the problem that we solved with the modern automobile and the interstate highway system. It just, it wasn't going to happen. So we shouldn't yell at the horse-drawn carriage. We should embrace the automobile.
Okay, let's see how you tackle this one. At a high level, how can data governance be incorporated into the cloud or lake without introducing more red tape?
It's a wonderful question, and it speaks to the challenge of traditional master data management, which is, it's essentially a red tape system. So, how do I impose red tape on the process to avoid bad data? At its core, we need to move from a system which imposes rules on users to one which kind of empowers them and lifts them up to provide feedback on data. So in a way, you should think of it as like the orthogonal opposite approach to the problem. Rather than imposing rules, how do we make people more effective and get the feedback that they have on this data, and then turn over the boring hard work of mastering that data to the computer? At its core, the idea behind Tamer, with the machine learning-based approach, is the work of mastering data is fundamentally, boring hard work. And what we, as generally a good strategy, is turn over boring hard work to computers, and then leave humans with the thing that they're best at. In this case, what humans are best at is providing feedback, and then we use that feedback to train the model to do the hard work of mastering data. And so it's exactly, the question implies exactly the right solution.
I would just say, I would agree that it's a balancing, it's part balancing, with the red tape. It's going to be a collaboration, between IT and the business, and between, people and technology, that could actually help to do this. I mean, I remember when I was at Bell Labs years ago, and I was analyzing some data, and I was first, just sort of going through the data, and I was using machine learning algorithms to actually find, data quality problems in the data. This was years before I was so ahead of my time. What can I say? But, when people said, how'd you figure that out? And then I showed them, and and we all sort of worked together to make it happen. So I just think people aren't going to go away, but they can make the best use of technology. So it's going to be a combination of lots of things.
Okay. Registered wants to know, how does anything that you've said today apply or not apply to public or nonprofits or government organizations like the Department of Defense?
I think the challenge of mastering data is most acute in exactly the industries you just enumerated. Like the government has tremendous sources of data, and there's huge opportunities to improve the service we provide citizens, teachers, government workers, our armed forces, et cetera, with higher quality of service if we can get a handle on the data. And this is a major focus for TAMR. Just to highlight a couple of examples, you may be familiar with the Department of Homeland Security has a system called GTAS, the Global Travel Assessment System, which works at the border to secure our borders and identify people that should not be crossing the borders. The data in that system is mastered through TAMR. But we also do work with the U.S. Air Force, with other use cases inside Department of Homeland Security. We work with a range of different U.S. intelligence organizations on things I can't tell you about. We work with NAVAIR, and then actually in DoD specifically, there's a system called JAKE, which is looking at aviation maintenance records. We talked about the example of parts mastering. It's a great use case inside JAKE at DoD. Anyway, the point is huge opportunities, lots of use cases, and a big focus for TAMR.
I have nothing to add on that topic.
All right. Well, thank you both. We're about out of time here, so let me take a moment to thank our speakers, Fern Halper with TDWI and Anthony Dayton with TAMR. And also, again, thank you to TAMR for sponsoring today's webinar. Please remember that we recorded today's webinar, and we will be emailing you a link to an archived version of the presentation. Feel free to share that with colleagues. And don't forget, if you'd like a copy of today's presentation, use the click here for a PDF line. Finally, I want to remind you that TDWI offers a wealth of information, including the latest research, reports, webinars, and information on business intelligence, data warehousing, and a host of related topics. So I encourage you to tap into that expertise at tdwi.org. And with that from all of us here today, let me say thank you very much for attending. This concludes today's event.